Welcome back to our presentation of the Chemistry 2 A level. Question 1. A. What does it mean by electrochemical cell? What does it mean by electrochemical cell? An electrochemical cell is just a device which is capable of generating electrical energy from chemical reactions. In other words, it is a device which uses electrical energy to cause chemical reactions. That's all what we mean by electrochemical cell. It is a device which is aimed at generating electrical energy from chemical reactions. The second one, you have to know the meaning of fuel cell. Fuel cell. Fuel cell is also an electrochemical cell that converts potential energy from fuel into electricity through chemical cells. It is also just a electrochemical cell that converts the potential energy stored up in fuel to electricity through chemical cells. A third is battery. What does it mean by a battery? A battery is a device which consists of either one or more electrochemical cells with external connection to provide power to electrical devices. The battery, it is a device which consists of either one or more electrochemical cells which contains external connection for providing power to electrical devices. Cell notation. A cell notation is just a shorthand description of a voltaic or galvanic cell. You are having a voltaic or electrochemical cell, then a short form for representing such a cell is known as a cell notation. That is A. B. What is the main type of reaction does the electrochemical cell use to generate an electric current? What is the main type of reaction does the electrochemical cell use to generate electric energy? The main reaction used by an electrochemical cell is a redox reaction. The main reaction used by electrochemical cell to generate electricity is redox. B Roman 2. Use Daniel cell as an example to explain the type of reaction you named in part 1 above to generate electric current. Use Daniel cell as an example to explain the type of reaction you named in part 1 above. We have named a redox reaction. Then Roman 2 requires us to use a Daniel cell as an example in order to explain the type of reaction we named in part 1 above. A Daniel cell is a cell which uses copper and zinc electrodes. So, zinc and copper electrodes. Therefore, we can go straight to the half reactions which are involved. This is an oxidation half reaction. This is the reduction of reaction. Then the overall is the summation of this one. So this is the overall redox reaction which generates electricity in the Daniel cell. C, question C says consider the following reduction potentials. Consider the following potential potentials. There are three of them. Now, questions arising out of this information. Number one, explain which metal between magnesium and gold is good to be employed as a rust protector of iron pipes buried in the moist soil. Between magnesium, gold, and iron, which one will be a good protector? Now, the criteria to be used when you are choosing a good metal protector is that a good one should have more negative potential than iron. It must be having a more negative potential than iron. If you write this one as an oxidation potential, then it will be magnesium this one will be and that one so between magnesium and gold, it is this one which possesses a more negative potential. Therefore, magnesium is a proper one to be used as a protector of iron. Then, Roman 2, calculate the EMF of the cell made up of iron and magnesium half cell, and between iron and gold half cell. EMF of the cell made up of iron and magnesium. So the oxidation potentials for these metals is positive and the oxidation potential for magnesium is minus 2.37. Therefore, EMF will just equal to the EMF of this one minus of this one, which is I minus therefore just if you do the arithmetic, then you get 3.14 moles. That was the cell made up of iron and gold. He said, just take this one, subtract this one. E. E. Then question 1, part C. Question 1, part B. Calculate the voltage required to bring about electrolysis of copper, of 1 molar copper sulfate solution at 25 degrees centigrade. You are given the standard potentials for that of copper and that of water stroke hydrogen. So this was electrolysis of 1 So let's assume assume in this case that the electrodes used are either platinum or graphite. Therefore, at cathode, a solution containing copper-2 sulfate possesses copper ions and hydrogen ions. And all of this one will migrate to the cathode. But copper will be discharged preferentially. Because it occupies an opposition in the chemical series than hydrogen. And at anode, the negative ions present in copper-2 sulfate aqua solution is sulfate ion and hydroxide ions. The hydroxide ions will be discharged preferentially. Now, such a cell, the EMF which produced is equal to 1.23 minus 0.34. Since this is the voltage, minimum voltage will be required to carry out this type of reactions to cause electrolysis of copper-2 sulfate. So the minimum voltage required is this one. The Roman 2. How many molecules of chlorine should be deposited from molten sodium chloride in 1 minute? How many moles of chlorine should be deposited from molten sodium chloride in 1 minute by a current of 300 milliamperes? So the time given is 1 minute, 6 seconds. The current employed is 300 milliamperes, which is equal to 0.3 amperes. We are required to calculate the number of molecules chlorine that should be deposited. The quantity of electricity is given by the product of current times time. So this one in current is 0.3 times 60, which amount to 18 coulombs. The reaction which deposits or which liberates chlorine is this one. This is a reaction which actually liberates chlorine. From the stoichiometry of this reaction equation, we are told that 2 moles of electrons are involved to effect this particular reaction. But 1 mole of electrons carries 1 Faraday of electricity. Therefore, the 2 moles of electrons carries 2 Faradays. Then, from this particular equation, we are given the information that 2 Faradays are required to produce 1 mole of chlorine. One Faraday carries 96,500 coulombs. So this one, 1 mole of chlorine. But we passed only 18. If this quantum electricity can produce 1 mole of chlorine, now 18 coulombs, it produces how much? If you do the cross multiplication, we get x is equal to 18 times 1 over 2 times 96,500. And if you do that one, you get therefore, from 18 coulombs, we've obtained 18 over 2 times 96,500 moles of chlorine. But we know that 1 mole of chlorine contains 6.022 times 10 to the 3 molecules. Therefore, this much moles we contain how many molecules? If you do the cross multiplication, you get x is equal to 18 times 1 over 2 times 96,500 times 6.022 times 10 to the power 23. If you do such a calculation, it amounts to 5.616 times 10 to the power 19 molecules of chlorine. Therefore, if you pass a current of 0.3 amperes for the specified time in the solution, having these ions, then it produces this amount of chlorine molecules. Let's go to question 2. Question 2. Roman 1. A Roman 1. Give 4 differences between order of reaction and molecularity of reaction. between order of reaction and molecularity. So, on one hand, you are having order of reaction. On the other hand, molecularity. Give the four differences between order of reaction and molecularity of the reaction. The first one, when we speak of order of reaction, it is just the sum of the powers of the concentration in the rate law or in the rate expression. The sum of the powers of the concentration of a substance in a rate law or in a rate expression is what forms the order of reaction. But molecularity of the reaction refers to the number of reacting species in a reaction. The number of species reacting in a given reaction gives us the molecularity. But order of reaction refers to the sum of the powers of the concentration in the rate law or in the rate expression. The second difference between order of reaction and molecularity of the reaction. Order of reaction can only be determined experimentally. You cannot deduce it theoretically. The order of reaction can only be determined experimentally. But molecularity of the reaction is determined theoretically. You theoretically determine. You write the reaction involved, and then you can know exactly the number of species which are involved in such a reaction. The third difference, the order of reaction may have fractional values. You can have half order of reaction. But molecularity of the reaction, it must be whole numbers. Molecular of the reaction refers to it's always whole numbers. Order of reaction, the third difference that they can be a fractional value. It can assume a fractional value such as half order of reaction, but molecularity must be a whole number. And then the first difference is that the order of reaction can be zero. But molecularity of the reaction cannot be zero. There must be a particular number of reacting particles, reacting species, but order of reaction can be zero. An extra, the fifth one, if you like, the order of reaction can change with conditions. The experimental conditions can change the order of reaction, but molecularity cannot change with conditions. That is 2A Roman 1. 2A Roman 2. The rate equation for the reaction you are given, the rate equation for the reaction The rate equation for the reaction is found experimentally to be you are given a reaction and the rate expression or the ratio for such a reaction. Then you are supposed to suggest the mechanism for the reaction. You are supposed to suggest the mechanism for the reaction. First of all, you must understand that the slowest step is the rate determining step. Therefore, since the slowest step is the rate determining step, then the rate expression involves species which are found in the rate determining step, which is the slowest step. This one, this shows that the rate determining step involves these species. If these are the steps, the overall add them, you get 2 plus this one now. This is our mechanism, because the mechanism shows how a reaction proceeds. From this mechanism, we can have our overall reaction, which is given by our question. So this will be the mechanism for such a reaction. B, 2B, briefly explain the following theories. Briefly explain how the following theories describe the rate of chemical reactions. The following theories explains the rate The first one is collision theory. How the collision theory do explain the rate of chemical reaction. According to the collision theory, for a reaction to occur, molecules must collide. Since it is a collision, and not just a collision in the right orientation. This one will cause a chemical reaction to occur. Therefore, the rate of chemical reaction is explained by the frequency of collisions of the reacting molecules. The higher the frequency of collisions, and not just collisions in the right orientation, the higher the rate of chemical reaction. The low rate of collisions will result in a low rate of chemical reaction. That's one. Two, transition state theory. How does the transition state theory explain the rate of chemical reactions? According to the transition state theory, before reacting molecules form final products, they should absorb kinetic energy and then form an intermediate product which is very unstable, known as the activation complex. These the reactants energy we are talking of the transition state theory. According to this theory, reactants, before are converted to products, they form an intermediate product X, which is activated This is a transition compound which is very short-lived because it is very unstable. As soon as the activated complex is formed, which is the transition compound, it breaks down to form the final product. Therefore, how do we relate this one with the rate of chemical reaction? The rate of chemical reaction will depend on how fast the transition compound activated complex is formed and how fast it breaks down to form the product. The higher the rate, or the easier the formation of the activated complex, which is the transition product, and the higher the rate of the decomposition of this one to final product, the higher the rate of chemical reaction. If the rate of decomposition of this one to final product is low, therefore the overall rate of reaction will also be low. This energy is reaction path. Reaction path from reactant to product through a transition product. Then Roman 3, activation energy theory. How does activation energy theory explain the rate of a chemical reaction? Activation energy refers to the minimum amount of energy which must be absorbed by reactants before they are converted into products. The molecules which can be able to react to form products must possess this activation energy. Therefore, the higher the percentage of reactants having this activation energy, the higher the rate of chemical reaction and vice versa. The lower the percentage or the fraction of reactants with this activation energy, the lower will be the chemical reaction. So, according to this theory, the rate of chemical reaction is determined by the percentages of reactants which possess activation energy. The higher the number of molecules having activation energy, the higher the rate of chemical reaction and vice versa. Now let's go to 2B. To see experimental data for the decomposition of nitrogen pentoxide. we are given experimental data for the decomposition of this one. So this data are in the following format. There's time in seconds, and then logarithm we are given data for the decomposition of nitrogen protoxide. Time, the logarithm of the concentration at various times. This initially was this one, at this second was this one was this one. Then, what is the order of reaction? Which means that we are supposed to test for the order of reaction. There are various methods to establish the order of reaction. One of them is the Getco method. If we want to test for first order of reaction, we must use the integrated rate expression for the first order reaction. This reaction is as follows. We can relate this one in the following way. This can be related in another form in this way. Because the logarithms, if you are dividing them, you can subtract. If you do so, then you can make this one as a sum of the equation. Now, if you have a plot of this against this one, you are expected to get a straight line. Why? Because this is an equation of a straight line. The slope of this line will be minus k over 2.303. And the y-intercept is this one. Therefore, plotting this one against t, it means that you are testing this data whether they come from the first order reaction. In other words, if a graph of logarithm of this one against time, if a graph of this one against this one gives a straight line, it is a proof that this data comes from the first order reaction. Why? Because this is the integrated rate equation for the first order. If you plot this data, you will find that you get such a straight line, and the y-intercept gives you this one. So at this location, you are having logarithm since plotting this data gives a straight line, this shows that the order of reaction is the first order reaction. Second, what is the rate law for this decomposition reaction? Since it is a first order reaction, the rate law for any first order reaction is this. This will be, it is the rate law for the first order reaction. Therefore, what is the rate law for this composite reaction? The rate law for this reaction is this one. Then 3, what half-life of the reaction one? What is the half-life of the reaction? After you've drawn your from the graph you made based on data, you can calculate the slope. So the actual value of the slope, you get it from your graph. And then this slope is equal to minus k over 2.303. The slope, you evaluate it actually from your graph. If you do so, the value of k obtained will be 4.82 times 10 minus 4 moles. We are looking for the half-life. Before you get the half-life, you must express the value of k. How do you get the value of k? From the slope of your graph you did, you evaluate physically this slope. It is a negative slope because it goes in this way. From the slope, you can evaluate the value of k. If you do it, you get the value of k is this much, the rate constant. Then we know that half-life for a first order reaction, when we started this, it is a first order reaction. For a first order reaction, half-life is given by 0.693 over k. If you substitute the value of k, which this one is equal to 0.693 over 4.82 times 10 minus 4. If you do so, you get 1.438 seconds. Question 2D. One centimeter cubed of ethyl acetate was added to 25 centimeter cubed of 0.5 HCl of the mixture. 0.5 m hydrochloric acid. From the mixture were withdrawn from time to time during the progress of hydrolysis of ester and titrated against standard sodium hydroxide solution. The amount of sodium hydroxide required for titration at various intervals is given below. So this is the hydrolysis reaction. The data given are time, So it is a reaction which was being withdrawn at various intervals and titrated against sodium hydroxide. In other words, what was being monitored is the amount of hydrochloric acid which are still present in the reaction mixture. If the reaction is first order, calculate the rate constant. For first order reaction, this is the integrated equation for the first order reaction. Where this one represents the initial concentration of the reactant, and this one represents the reactant remained in the reaction mixture after time t, where K is the rate constant, T is the time. So we are supposed to calculate the rate constant. The amount the concentration are being taken to equivalent to the volume of sodium hydroxide used. The higher the volume of sodium hydroxide used shows that the hydrochloric acid is much. The less this one used, it means that the HCl is also less. So from this one, we can express the value of K. To express K, in this case, K equal to 2.303 equals in our particular case, this one the initial volume expressed as the difference in the volume of solvent oxide used at infinity time and at time 0. If you substitute this one into this one, we get K equal to 2.303 over T logarithm of V infinity minus V 0 over V infinity minus V T. We are supposed to express K at various times. At this time, at this time, at this time, at least 3 of them. And then the average of those K will give us the overall rate constant for that particular reaction. Therefore, K1 equal to 2.303 T is 20. The infinity is 43.95 minus V naught, which is 20.4. Divided by V infinity, which is 43.95 minus Vt, which is 21.73. If you do so, you will get 3 times 10 power minus 9 per minute. You do the same for K2. In this case, at this time, the time is 75. This one is constant throughout. If you do so, you get 3.13. You do the same for K3 and K4. And then so in short, you just calculate the rate constant at various times by using the integrated rate equation for the phase of reaction. Then the average of those various rate constant at various times will give you the overall rate constant for your reaction equation. Question 3. The bottle of Kilimanjaro drinking water is labeled pH is equal to 7. Chemically, what does it mean? If a bottle of Kilimanjaro drinking water is labeled pH is equal to 7, what does it chemically mean? It means that the pH of this water is, it means that this water is neutral. It's neither acidic nor basic. That is, it is neutral. Hence, the concentration of hydrogen ions in that particular is 10 to the power of hence, the concentration of this, chemically it means the water is neutral, which means that the concentration of hydrogen ions and that of hydroxide ions are equal. That's what it means when we say the pH is 7. It is neutral, which means neither acidic nor basic. And chemically it means that the concentration of hydrogen ions is equal to that of the hydroxide ions. Roman 2. After eating bread contains 16.8 grams per liter of excess anti-composting baking powder, how much volume of water contains 0.1 m carbonic acid? B. Calculate hydraulic constant. For acetic acid, given Ka value is 1.8 times 10 to the power minus 5. Since hydrolysis constant is given as the ratio of Kw or Ka. And Kw is 10 to the power minus 14, and this one is 1.8 Kw is 10 to the power minus 14, which is a constant. It is a constant, but this one should be given. And if you do the calculation, you get 5.2. That will be the hydrolysis constant for acetic acid if its Ka value is 1.8 times 10 to the power of minus 5. And B2 calculate the degree of hydrolysis. The degree of hydrolysis. The hydrolysis is given by the formula KEW over C Ka, where C stands for concentration. So this one, KW is 10 to the power minus 14 over the concentration was 0.1 times Ka is 1.8 times 10 to the power minus 5. If you do the calculation properly, you get 7.45 times 10 minus 5. So the degree of hydrolysis is that much. Then row 1 3 for the same question. Calculate the pH. N acetic. Sodium ethanolate.